Now that we've learned how to conduct hypothesis tests for paired data, it's time to remind ourselves of our old friend, confidence intervals. That's right. We need to make confidence intervals, but this time for paired data. Now, it's been a couple chapters since we've seen confidence intervals, but just remember, you don't have to memorize the formulas for these things because they're right in your inferential statistics sheet packet on the first page. So you can see we've done all the ones from chapter 9 so far. And rather oddly, we're starting off with 11.2, which is for dependent samples. When you have two samples and they're dependent, that's a t-interval. And there's the formula, d bar plus or minus t alpha over 2 sd over the square root of n. All right, t alpha over 2 is a critical value. You find that from your t-table with n minus 1 degrees of freedom. And then your point estimate is your d bar. And then these instructions are how to do it with a calculator, but that won't be a problem because we're about to do it with a calculator. All right, let's look here. So our formula right here is d bar plus or minus t alpha over 2 sd over the square root of n. Now, if you recall, we actually have these data in stat edit. There you see list 3 right there has our data set, right? Because it was list 1 minus list 2. Right? The before the Reiki touch therapy minus the after. Okay, so we wanted to find the sample mean and the sample standard deviation. So we ran one variable stats on this. So I'll just remind everybody. Although I'll give you a hint, you actually don't have to run one variable stats. There's another way to get it, which we'll show you in a second. So 1.923 and 1.605. So that part's all set. Now, you might be thinking, okay, well, that's all well and good, but I'm going to need my t alpha over 2, right? So let me put this in 1 second. There we go. So we have almost everything substituted in, but we have to go find the hardest part, which is actually the t alpha over 2 part. So remember, your confidence level is 95%, and that means alpha is 0.05. Okay, so if alpha is 0.05, then alpha over 2 is 0.025, right? And that means your degrees of freedom, 0.025, that would be your column. So let me put that in. That's your column that you go to in your, I must have my caps lock on, in your t-table, right? Column. And then your row would be 12 because that's your degrees of freedom. So that would be your row. Or you could just put inverse t in your calculator. 0.025 comma 12, and it will tell you that it's 2.179. So let me pop that in there. And then let me bring up the table just to show you real quickly. So 0.025, go to the 12 row, and there it is, 2.179. All right, so that is our t alpha over 2 value. So let me type that up in here. So 2.179. And then we want to get the results, all right, our final results. And actually the final result part is actually the part that would allow you to not have to do one variable stats. Let me show you what I mean. So up right here, when it says to do the two sample dependent samples, it says use the t interval right there. Okay, so let me go to the calculator, go to stat, go to tests. T interval is number 8. If you have an older calculator, it won't be on the initial screen, but it's down there. If you go down to number 8, you'll see it. You want to pick T interval. Now we actually have our data in L3. So if I run it off of data in L3, I tell it I want a 95%, go down to calculate and enter. When it finds the interval, it actually finds the X bar value and the S value, and the N for that matter for us. So if you never wanted to run one variable stat again, you didn't have to. You could do the T interval right there. But you'll get 0.95302 and 2.8931. And I kind of rounded that just a little bit to 0.953 and 2.893. And just on a side note, remember quickly that stats is just in case you have the statistics to begin with. So if you pick number 8 and you tell it you want stats, that would mean, hey, I don't have a column of data, but I could type in my X bar and my S for myself. So 1.923, 1.605, 13 was my sample size, and so on. I go down to calculate and I run it. They'll be tiny bit different because I've lost a little bit of accuracy, but that's okay, right? It's close enough. So I get 0.953 and 2.893. All right, now what is the point estimate? Well, it's been a while, but remember that the point estimate is the center of your interval, which in this case would be d bar because you add and subtract away from that d bar value. All right, so the point estimate would be d bar, which is 1.923. And just a little remember that the point estimate is exact center of that mean, or excuse me, exact center of the interval for that mean. Right? That isn't always the case. It's the case for all of them, except for the ones for chi-squared, the ones for the variance and standard deviation. All the rest of these with the plus or minus business, they always have their point estimate as whatever is that front half part before the plus or minus. That's the point estimate. So the one we're in right now, it's that d bar before the plus or minus. The only interval that doesn't work that way, where the point estimate's not in the center, are these two right here, because they work off of a chi-square distribution, which is skewed right. All right. Oops, I need to close that. We don't need that anymore. Now we need to compute the margin of error, but let me remind you how this works. So, because it's been a while since we've seen confidence intervals. So the way a confidence interval works is you have your lower end at 0.953, you have your upper end at 2.893, and I put this on a number line, 0, 1, 2, 3, so you could see. All right, and then D bar is right there in the center, right? That's what I was just saying here, that it's the exact center of that interval for a mean. All right, so matter of fact, you know what? Can I just say of the T interval for the mean? Okay. All right, so then the margin of error is that distance from the high end to the low end cut in half. In other words, it's the distance from the middle to the high end, half the width. We learned that way back in chapter 9, that error is half the width. So you take your high number minus your low number and you divide it in 2. So we would take 2.893 minus 0.953, find what that is, and then divide it by 2, and you get 0.970. All right, and that's where that comes from. So it's been a while since we saw it, but error is half the width. Remember that. Oops, I better not do that. It's not going to like me, but suffice to say, that's an important little idea right there. All right, now what does this mean for our situation? How do we interpret this confidence interval? Well, we're 95% sure of something, right? So we are 95% sure that, and this was that Reiki touch therapy data, so that the mean difference in pain levels before and after Reiki touch therapy is somewhere between 0.953 and 2.893. Let me type that up and put it in here. So we're 95% confident that the Reiki touch therapy lowers pain level scores. Remember, we showed that it lowered them because the group 1 was the before and group 2 is the after. So it's made them go down somewhere between 0.953 and 2.893 on the pain scale. For the chronic pain sufferers, right? Chronic, as I recall, they were back pain sufferers, but I don't really remember. Actually, no, they were just chronic pain sufferers, period. Some of them were cancer patients, some weren't, that kind of thing. All right, so we're 95% confident that the Reiki touch therapy lowers the pain levels scores from between about 0.953 and 2.893 on the pain scale. Now, this is kind of awkward phrasing. Let me change this and lowers the pain scores for chronic pain sufferers from between 0.953 and 2.893 on the pain scale. And the pain scale, there we go, goes from 1 to 10. That's a little bit better. Sorry to do that to you, but it just was a little awkward in phrasing there. So we're lowering the pain level scores for these chronic pain sufferers from somewhere between about 0.953 to 2.893 on the pain scale. And the scale goes from 1 to 10. All right, does this confidence interval imply that there is a significant difference in the pain levels? Now, this is going to be a pretty deep thinking about it question that's going to have repercussions for the rest of this chapter. So let's ponder this for a second. Right. If there were no difference in the pain levels, if the before group and the after group were the same, then that would mean that the null hypothesis were true. Okay, so let me write that up. And by the way, the answer is yes. This particular confidence interval is showing us that there's a difference, but let me prove it to you. So if there was no difference, right, no difference at all, then that would mean that the average pain levels before and after would be the same, right? And if they're the same, that means your null hypothesis, which is that mu d equals 0, is true. Okay? However, mu d equals 0. Remember how in chapter 11, in your inferential statistics packet, for chapter 11, it's always that the mu value is equal to 0 for your null hypothesis, always. That's the way the whole chapter is. Okay, so if there was no difference, then the pain difference between the two would be 0 when you subtract them. So for example, a patient of 5 before at pain level would have a 5 pain level afterwards, that kind of thing. However, 0 is not in our interval. Look, 0 is over here. I drew it in there for a reason. 0 is way over to the left. Right? Since our confidence interval does not contain 0, that implies that there is a significant difference in the two groups. If 0 was in the interval, there would not be a significant difference. Our confidence interval does not contain 0. That implies that there is a significant difference in pain levels for the groups. In other words, it appears to be showing that mu d is not equal to 0. And of course, I use the words appears because we don't know this for sure, right? We can't prove that this therapy works. What we're doing is showing evidence that supports that the therapy works. That's a very different thing. It's the difference between saying innocent and not guilty. We don't know that this works. We just show that it's likely that it works. And that's because 0 is not contained in the interval. Again, your null hypothesis is always 0. So you're always in this chapter looking at 0. Is 0 in that interval or not? If 0 is not in the interval, that implies that there is a significant difference. All right, we're all done with that confidence interval example. Now see back here for the next video when we'll do one where the computer's done a lot of the heavy lifting for us and we have to analyze the results. Those are the kind I love to give on exams.